Good day everyone, I'm Eugene De La Cruz and I'll be discussing how to analyze simultaneous games. So let's consider this problem. The following payoff table involves two players each of whom has three possible moves. First, are there any dominant strategies in this game? Second, is there any dominant strategy equilibrium? Third, are there Nash equilibria? If so, determine how many and state which strategies. And lastly, solve using IESTS. So let's first focus on the first question. Are there any dominant strategies in this game? So as we have defined earlier, a dominant strategy is any strategy with payoffs no better than those of at least one other strategy, regardless of the choice of the other player. So let's first consider the strategies of player A. So considering player A's strategy X, we can see that the first one is already being dominated by strategy Y since 2 is less than 3. Therefore, therefore, player A strategy X is not a dominant strategy. Next, strategy Y. So for the first one, it is the dominant one since 3 is greater than 2 and greater than 1. For the next one, 1 is equal to 1 and is greater than 0. However, for the last one, 2 is less than 4 and is less than 3. Therefore, strategy Y is not a dominant strategy. Lastly, strategy Z. So it is already being dominated by both strategies X and Y, therefore strategy Z is not a dominant strategy. So therefore player A does not have a dominant strategy. But what about player B? So let's consider strategy X. So strategy X have a payoff of 0 which is being dominated by 1 and 2. So strategy X is not a dominant strategy. Next, strategy Y has a payoff of 1 which is being dominated by 2. So strategy Y is also not a dominant strategy. Lastly, strategy Z. So 2 is the dominant one here since 2 is greater than 1 and greater than 0. However, 3 is being dominated by 4. So strategy Z is not a dominant strategy. Therefore, player B also does not have a dominant strategy. Since both players A and B does not have a dominant strategy, therefore, the game does not have any dominant strategies. And since the game does not have a dominant strategy, it also means that the game does not have a dominant strategy equilibrium. So for the next question, are there Nash equilibria? If so, determine how many and state which strategies. So as defined earlier, a Nash equilibria is a list of strategies with one strategy per player such that each strategy on the list is the best response to the other strategies on the list. So it is basically the strategy that yields the best payoff considering the strategy that the other player chooses. So let's first take a look at the strategies of player A. So if we assume that player B chooses strategy X, what will be the best strategy for player A? So if player B chooses X, then player A will either get a payoff of 2, 3, or 1. So obviously the best one here is 3. But what about strategy Y? So player A could either get 1, 1, or 0. So we will box both ones. Lastly, for strategy Z, the best one is 4, since it is greater than 2 and greater than 3. Now, let's consider player B. So if player A chooses strategy X, player B could either get 0, 1, or 2. So the best one here is 2. What about if player A chooses strategy Y? Player B could get 4, 2, or 3. So the best one here is 4. And lastly, if player A chooses strategy Z, player B could either get 3, 2, or 0. So the best one here is 3. So now we can see here that the Nash equilibrium are 3, 4 and 4, 2. So therefore, there are two Nash equilibriums in this game, and these strategies are x, z and y, x. So lastly, solve using IESDS. So IESDS stands for Iterative Elimination of Strongly Dominated Strategies. So it can be used to find Nash equilibriums. So assuming that we do this correctly, then the answer that we should get here should be the same as the one earlier since it is the Nash equilibrium. So what we do here is to reduce the number of outcomes to be considered in the game. So we basically eliminate all of the dominated strategies. So let's take a look first at player A strategies. So here at player A, at strategy X, there's 2, 1, 4. So the least one here is 1. So therefore, strategy that has a payoff of 1 is the dominated strategy. And as we can see as well, for player B, this is also the most dominated strategy. Therefore, we can eliminate this column. How about here in the second row? So we can see here that there are no dominated strategies. Well, there are weakly dominated strategy. However, there are none that is being strongly dominated. So there are none that can be eliminated for this row. But the last row, all of them are being strongly dominated by the other strategies. Therefore, we can eliminate this strategy. So by IESDS, we can now remove these strategies. So we are now left with a 2 by 2 table. So by considering this table, we can see that there is no particular strategy that we can eliminate. So we must now look at the individual cases here or the individual actions that each player can take. So if player A chooses strategy X, then the best payoff for player B is 2. So for this one, this is the dominated strategy, the 2, 0. But if player A chooses strategy Y, player B has 3, 4 as the best strategy. So 2, 3 is the dominated strategy. And the same goes with player A. 2, 0 will be the losing strategy for player A and as well as 2, 3. So therefore, we can eliminate 2, 0 and 2, 3. Therefore, we are now left with 4, 2 and 3, 4, which are the Nash equilibriums of this game, which are the strategies x, z and y, x. So these are the same as the answers that we got earlier at letter C. So therefore, whichever method that we use, we should still arrive at the same Nash equilibrium.